Hi everyone, welcome to AI Exact channel. This is Akash Kingwar and today we'll be studying limits lecture 3. So this is the second last lecture of limits, and after that we'll have a short lecture 4 basically. So let's get started. This is QOD 4. Actually, when I posted this in the group, I had this mistake over here. That is x tends to infinity. In the group I have posted with x tends to 0. That is not correct. Just correct it over here. X tends to infinity. Now let's get started. So today we'll be studying few more standard limits, basically trigonometric standard limits. And the first one is sin x by x or x by sin x. That is equals to 1 when x tends to 0. Now you can see that derivation is very simple. In all these four cases, derivation is very simple. You just have to apply L'Hopital rule and you'll get the answer as 1. Now what is the utility? Let's take an example first. Let's say we have 10x minus x cube divided by again x cube over here. Maybe x4 over here. Let's say. Now, when I'm trying to apply the L'Hopital in the numerator part, I'll get sec square x minus 4x cube divided by 3x square. Now, this one becomes increasingly difficult to differentiate in the further steps. Let us assume that this stays 0 by 0 over here as well and in the subsequent steps as well. So you'll have to differentiate this term. So basically you'll have to apply product rule, and after that it will get increasingly difficult. So in those cases, basically these standard trigonometric limits will be very helpful. After this, we'll be studying expansion that makes things even more simpler. But let's look at first trigonometric limits. So you can easily derive these ones with the help of L'Hopital. Now let's take a few more examples to understand the basic properties of these kind of limits. Let's say we want to calculate sin x by x limit x approaches 0. Now what? Now we know that y equals to x is like this and sin x is like this. So you'll have to understand this graph. Basically, at all points y equals to x is greater than sin x. That is what I mean to say. At all points from 0 to infinity or from minus infinity to 0, y equals to x is greater than sin x in case of magnitude, right? So basically this ratio will always be less than 0, right? Less than 1, sorry. This ratio will always be less than 1, right? So even though the limiting value of this function is 1, but in terms of numerical value, it will be always less than 1. So basically 0.9999, something of this sort. Close to 1, very close to 1, but always less than 1. So whenever I'm taking GIF of this function, if this sin x by x, in that case, that will be 0. Now if we do the opposite, x by sin x, in that case that will be 1, because that will be 1.000000 something 1, right? In that case that will be like this only, and we'll get x by sin x gif of this function as 1. So you can this can be asked in the examinations. Similarly, we can see that, let's take for example for tan x. Now let's talk about x by tan x by x first. Now let's plot the graph once again. So this is y equals to x. Now we know that tan x looks like this. So now in this case, the opposite is happening. So basically for every x, magnitude of tan x is always greater than x. So basically this ratio is always greater than 1. However small the value of x, this ratio is always greater than 1. Very close to 1 maybe, but always greater than absolute 1. Now in that case, if I take the GIF of this function, that would be absolute 1, right? And if we take the reverse one, x by tan x, in that case, that would be 0. So you can find out the similar kind of results for all these ratios. Sin inverse by x, that would also be in case of sin inverse by x divided by x. In that case, this ratio would always be greater than 1. So GIF of this function, this particular function, that again will be greater than 1. So you just have to plot the graph and you can do this practice at home. Now let's start with the another standard limit. 1 minus cos x divided by x square. Again, derivation is based on L'Hopital only. You just apply, you just differentiate the numerator and denominator and you will get this result. Let's try to see this application in the examples. So let's look at illustration 1. Now here we have been given that 10x minus sin x divided by x cube. But we know that 10x by x is favorable, sin x by x is favorable, but we have got x cube over here. So that this doesn't make sense, right? This doesn't actually make sense. So what we have to do, what I'll do, I'll convert tan into sin x by cos x, the usual thing which we do in trigonometric formulas, right? And I know that cos x is somewhere related to 1 by x square. So that is why I'm also thinking to convert tan x into sin by cos. Now let's take sin x as common. I'll get 1 minus 1 by cos x minus 1 into 1 by x cube. Now I can see something is forming over here. So basically sin x by x, I'll take x over here. So this becomes favorable. Now what will happen? 1 minus cos x, I'll take x square over here. That also becomes favorable. And I'll do this one. Now with the basic algebra properties, we saw that when individual limits are existing and finite, then multiplication would also exist, right? So this one is existing and finite. This one is also existing and finite. And this one too also existing and finite. So basically limit x tends to 0. In this case, that would be 1 into 1 by 2 into 1. So basically 1 by 2. So here we can see the application of algebra of limits, which we have studied earlier, right? Now let us look at another example. It says limit x approaches pi by 2, 1 plus cos 2x pi minus 2x whole square. Now this looks favorable because we have cos 2x over here. We have pi minus cos 2x whole square over here. So I can sense that something favorable is being posted over here. But this is not exactly totally favorable. We'll have to convert it. So I can see pi minus 2x over here. So I should have pi minus 2x over here and with a minus sign over here. So what should be done? So basically what I'll do, I'll write 1 plus cos of pi minus 2x and with a minus sign over here, right? I can write this way based on the allied angles concept. And after that, I'll write pi minus 2x whole square. Now things becomes favorable. So this is basically approaching 0. This is also approaching 0. So 1 minus cos, let's say t, 1 minus cos t divided by t square. So that becomes half, right? So that was fairly simple. Now let's look at this example. It says x square minus x minus 2 divided by x square minus 2x minus sine of x minus 2. Now this is a 0 by 0 case where x is approaching 2. Now this equation at the first look, it looks a little scary because it's too lengthy with sine over here and a polynomial over here. But it's actually not. So basically my first starting point should be to look at the argument of the trigonometric ratio. So basically we have x minus 2 over here. So I have to generate something around it only, right? So I can see that we have x minus 2 as a factor over here. So x minus 2, I'll write it as x minus 2 plus x multiplied by x plus 1 divided by, I can again see x minus 2 as a factor over here minus sine of x minus 2. Now I can see things being simplified. So basically what I'll do, I'll take x minus 2 common from both numerator and denominator. I'll get x plus 1 over here, x minus sine of x minus 2 divided by x minus 2. Now things look very simple. This gets cancelled out. And this limit is existing and finite. This is also existing and finite. And this is also existing and finite. So we can add, subtract two finite limits, right? According to the algebra of limits. So basically what we'll get from here, we'll get 3 in the numerator, 2 minus 1. Basically 3 is the answer, right? Got the point? Now let's look at one final example. Says a raised power x minus 1 minus 1 divided by sine pi x. So this is a combination of basically two standard limits. So one is exponential and one is trigonometric. Now let's see how do we proceed with it. So basically we'll see at the numerator first. It needs one more x minus 1 in the denominator. So I'll divide and multiply with x minus 1. So a raised power x minus 1 divided by x minus 1. So this is one standard form. And over here we'll get x minus 1 divided by sine pi x. Now this doesn't look like to be a standard form because we don't have x minus 1 over here. Now with the help of allied angle concepts, I know that sine pi minus pi x equals to sine pi x. Basically sine pi minus theta is sine theta, right? Now I can write this as minus of sine pi times x minus 1. I just shifted the sign and took the minus sign over here. That is also sine pi x, right? So I'll write this one as this. So x minus 1 divided by minus sine pi times x minus 1. But now we have pi extra over here. We don't have pi over here. So I'll again multiply and divide. So we have got, this is 1 over here. Sorry, ln a over here. So this is ln a. So ln a into, so this becomes minus 1. So minus 1 by pi. So minus ln a by pi. This is the answer. So let's start the last topic for today's lecture, that is Taylor series expansion. So the derivation part for these expansion series is not really important, and it's not really important for PGDBA basically. So you don't have to understand it properly. You can see the derivation part, but more or less you have to remember these formulas in the exam during the examination. So there are 6 formulas: a raised per x, e raised per x, ln of 1 plus x, sin x, cos x, tan x. You don't have to remember tan inverse, sine inverse, cos inverse. Though those are additional formulas. If you wish, you can learn, but you won't be using them in the actual examination. So let's try to implement these expansion series in the examples. So I'll explain the application over here as well. Now let's look at this example. It says e raised per x minus e raised per minus x minus 2x divided by x cube. Now this is the most important term in this entire function, in this entire question. How? So let's say we can write the upper expansion, the upper numerator part, we can write it as a times x plus b times x square plus c times x cube plus d times x raised per 4 plus e times x raised per 5 and so on. Because this is an infinite series. You can see that this is an infinite series. It keeps on going. Divided by x cube. Limit x tends to 0. Now if limit has to exist, in that case, this should be 0. The coefficient of a should be 0. Sorry, coefficient of x should be 0. Basically a should be 0. B should be 0. And we can also ignore these terms because these are higher power terms. So basically as compared to x cube, this is extremely small. So basically if x is 0.00001, and then in that case x is per 4 will be even more small. So that way we can neglect the higher order terms. So these portions is this portion is being neglected, but over here a should be 0 and b should be 0. In only that case this limit will exist, and that would be c by 1. In this case, let's say we have 2 over here, in that case c by 2 would be the limit. So this is how we have to solve. Now let's try to solve this one. So over here, we know that e raised per x equals to 1 plus x square by 2 factorial plus x cube by 3 factorial and so on, right? So I'll be writing as the same. We know that we just want x cube over here. So I'll not be writing terms of higher power. So that will give me 1 plus x square by 2 plus x cube by 6. Only this much. Minus 1 minus x plus x square by 2 minus x cube by 6 and minus 2x divided by x cube. Now you can clearly see that this constant term got cancelled because we cannot have a constant term in the numerator, otherwise limit won't exist. Similarly, this and this got cancelled. So this became 2x, this minus got over here, x plus x 2x minus 2x, that got cancelled. Similarly, x square by 2 got cancelled because that is again a smaller power than x cube. Only the remaining term is this and the higher power terms which we haven't written. So that will become 2x cube by 6 into x cube. So basically 1 by 3 is the answer. So this is how you have to solve the expansion series. So let's look at this example. It says x minus x square ln of 1 plus 1 by x. So first of all, I'll convert this into a standard form because that would be ln of 1 plus t of 1 plus x or 1 plus t, whatever. So I'll write x as 1 by t. In that case, it will become limit t tends to 0, 1 by t minus t square ln of 1 plus t, right? Now this will become t minus sorry, this is 1 by t square. T minus ln of 1 plus t divided by t square. Now I will write expansion over here. So it becomes t minus, that will be t minus t square by 2 plus t cube by 3 and so on, divided by t square. So this gets cancelled. You can see that this automatically gets cancelled. And this becomes t square by 2 minus t cube by 3 and so on, divided by t square. So the higher degree terms gets cancelled, it gets neglected basically. So the only term remaining is t square by 2 divided by t square. So we get half as the limit. Now let's look at one last example. It says fx equals to 4 plus sine 2x plus a sine x plus b cos x divided by x square. So if limit x tends to 0, fx exists and finite, find the value of a and b and the limit. So we have to use that concept. So basically, we'll be getting common constant term over here in the numerator. We'll be getting term of power x. So we have to make them 0 because all we need is the term of x square in the numerator and the higher degree terms. So let's see that. So that will be 4 plus sine 2x would be 2x. So basically consider 2x as t. So t minus t cube by 3 factorial, that is 6. And so on. We'll not be writing the higher degree terms, right? Plus a times x minus x cube by 6 plus b times 1 minus x square by 2 plus x4 by 4 factorial and so on, divided by x square. So the constant term we get is 4 plus b. So this one and this one, we don't have any other constant term. Now for x, for coefficient of x, we get 2 from here, we get plus a from here and no other term. Now for x square, we have only b over here. We don't have any x square term over here. So we have just got b over here and so on. We won't be writing for x cube or x4, right? Divided by x square. Now we know that for this limit to exist, only this coefficient should not be 0. All of them should be 0. So basically 4 plus b is 0 and 2 plus a is 0. So we got b equals to minus 4 and a equals to minus 2. So we got the answer of a and b from here. And limit would be b by 1. This ratio, basically this by this ratio. So b is minus 4. So we'll be getting minus 4 as the answer. Oh, this b by 2 would be, so sorry, minus b by 2 would be here. Of x square is minus b by 2. So we'll be getting minus b by 2 over here. So that would be 2. Yes, 2 is the answer. So today's lecture was till here only, and I hope you are enjoying this limit series as well. Basically, calculus has started in full force, and after that we'll be studying continuity, and probably in this week only we'll be completing continuity and derivability. After that we'll be starting with integration, AOD and integration. So let's meet tomorrow for the next lecture. Thanks for watching.